Alright, this is Doozer Shop. Welcome. Bringing you cool machines from the far-reaching ends of the globe, starting in my shop. I've been working on the Pratt & Whitney 2A. I've got the DeAndrea. This is a Model 2 DeAndrea. It's not the smallest one, it's a little bit bigger. 2 and 3 were kind of the same. This DeAndrea I bought on eBay a couple years ago. I think I paid $1,600 for it, which is a lot of money. But it had the adapter to screw on to the spindle of the Pratt & Whitney quill, you know. If you're not familiar, this is a 3-inch, no, I'm sorry, 3-inch 4 threads per inch. So this is a 3-inch diameter thread, 4 threads per inch. This is the collet nose cap. Look at that Higby start there, hey? Nice. If you don't know, that's what a Higby is when the thread is milled to start easily. Like fire hose couplings are this way. Anyways, yes, the adapter with this DeAndrea was made to fit this mill, and it didn't even say it in the ad. Doesn't matter. Anyhow, one of the things, let me show you first. Let me kind of kneel down. Oh, I got this table. I got it all scraped and cleaned. It was rusty and nasty. Oh, I put some time into that. So the way this works, it's a dovetail that mounts that block. And that's how the boring bars mount to the DeAndrea head, is you need a dovetail type block. So I didn't have one, loosen my screws, so I made one, okay? Just go boom, boom, boom. Man, is it a tight fit. It is a money for money fit. Okay. Alright. So, there's the dovetail, right? Maybe I'm not showing that too well, but there's a dovetail in there. And this is the mating. 60 degrees, 60 degrees, right? So that's what that looks like, is a, it's just an 1.5 by 1.5 block of steel. I don't know what this is, it could be 12L14. But anyhow, I set this up to accept 2 bars that are 3/4 of an inch and 1 bar that's 1 inch. And you can see here I got enough wall thickness, whatever you want to call it, wall thickness for a set screw. And here the wall thickness got a little bit less, so I put the set screw to retain the bar on the side, and I moved the bore in a little bit to give me back my wall thickness, because I don't want to strip these threads out. And I also I undercut, in case there's a burr where the set screw is, you might be able to see I undercut in case it raises a burr on the bar. There's a little undercut thingy in there. I just used an end mill to give it some clearance, because you don't want to seize up a bar in there. But I got this made, I don't know, it took me 2 days of fiddle farting, monkeying around to make this in 2 days. Not hard at it, definitely not 16 hours, maybe 8 hours of time just fiddle farting around with this. But I'm pretty happy with that. That took a while, and it fits like, you know, perfect. Okay. So that's the quill, that's the adapter, and this is the head. And you have to keep this from rotating, right? So let me take you around back. And I kind of struggled with designing this, and I had something elaborate figured out, and I ended up making something stone simple. So this attaches, let me reposition my hand on the camera. It's retained by some screws that go to the quill housing. I don't know how good you can see that. There's a couple 1024 flatheads up under there, right? Sorry for the shakiness. And anyhow, it's got a slot in it. So, you know, this I'll leave on the machine. And I made it out of aluminum, and it thins down to 1/8 inch in there, because if anything is going to break off, I want this to break off and not hurt the flathead screws threaded into my quill, because if it damaged that, that would be terrible. But I got it on here. I got just a screw, a 1/4 inch Allen head screw. I'm going to take the mounting bolts out, and I'll show you. And it's going to fall. I'll show you the adapter piece. I mean, I might as well take it off to show you the camera here for. All right. Okay. All right. So that's the piece, right? And there's some holes in this ring. You know, this whole body is free to rotate, right? You don't want that, because it's a facing head, and you got to have some. It's like a tapping. Heads have to be restrained also. So that's what I came up with, is this guy, right? It's just a boomerang looking affair. I cut this radius with the boring head in the Bridgeport. This started off as a rectangular piece of aluminum stock, of course, and then I just cut it out with the bandsaw, and I just radiused some of that stuff over with the belt sander. I traced out a radius, and then I sanded to the line on the belt sander. So this is, it looks cool, but it's not that hard of a thing to make. You just got a lot of measuring and a lot of, you know, monkeying around. So, but yeah, again, that tab will stay on there, and I got the slot bigger than I need to be, but it's kind of cool. All right, well, that's that. I'm pretty happy now. I get to use this. I got to put this back together now, but this thing's 100% usable. You know, so that was a fun little project. But I'm trying to get every accessory able to be used, and these little, you know, knick-knacky things, not having something to hold the bars, and not having a retention thing to keep it from rotating so I can use the facing feature, was holding me back. So, all right, we'll show you something else. Don't remember if I showed this in one of my other previous videos, but if not, I'll just go over it quick again. It's my Doozer grinder. It's a you know, handheld die grinder, and I wanted to grind some chuck jaws. So I just made these aluminum pieces that clamp on the, you know, the nose bearing, and that they're split, and they clamp on the motor, and, you know, it's got a base. It's just 3 blocks of aluminum with some layout and some work on the Bridgeport, and it's just got a 1/2 inch bolt. 1/2 inch, you know, 1/2 screw, bolt, I forget what you want to call them. Call them what you want. But this allowed me to grind my chuck jaws 3 pieces of aluminum, some drawn out on a napkin, some measurements, and just, you know, just figure it out and make it. I didn't record the making of it. It's just standard milling Bridgeport work, but yeah, this worked Cadillac for grinding my chuck jaws. Let me take you over there and I'll show that to you right now. Alright, the chuck for the Pratt & Whitney lathe is this, it's a buck-6 jaw, and 3 jaws were missing. And, which is okay. I think I should make some aluminum covers for the unused slots, but at any rate, so these slots either worn a little or the chuck is sprung, which means somebody over tightened it, and it, you know, I think it bends these. Can you see how the jaw runs in a T-slot of sorts? And, you know, these inner, they're not separate rails, they're part of the chuck body, but let's call them rails. These rail features, I think when somebody really tightens the chuck, it bends these, you know, probably more towards the center. So when you tightened something with the chuck, it would grip in the back. See the serrated jaws? It would grip in the back, but the front, I mean, you could see daylight in there. I mean, you could see 10,000ths, I think. So that was no good, because what you do is you try to tighten the chuck as much as you can, and even the front of the shaft or your stock is loose. I mean, it's not touching in the front, so if you really grab it or hog on take a heavy cut, it'll move. It'll it'll start wobbling. So that's what I wanted, that Doozer grinder, and I built that aluminum frame to mount it and grind these jaws. So that's something you can do, grind the jaws, but you have to preload the jaws. You have to, like, you tighten up the chuck and then grind them. So the only way you can tighten it, you got to simulate gripping a shaft or something. So I drill these holes in there, okay? These are 3/16, you know, 0.188 inches. And I think I had a 199 or a 200 drill or something. I had a carbide drill bit, so I drilled these in the Bridgeport. I took the jaws out and I clamped them in the vise. And I think they're only drilled 1/2 inch deep or something. But I was able to put 3 dowel pins in there, you know, 3/16 dowel pins. And I squeezed on a pipe, right? So, all right. This is just a scrap pipe. I don't even know what it's from. I think it's a cat head with all the holes in it. So what you do is you squeeze it, and I'm not going to adjust the chuck, but pretend, you know, there's a pin in there, and you just squeeze on the outside. Let's even pretend better. Yeah, you squeeze the pipe piece with the pins, and then you can see, and I should have this open, you know, there's room inside where you can put the grinder wheel. You know, it'd be loading using that, you know, piece of pipe to squish. And I got it tight enough where I was worried about breaking those pins. I should have drilled them for 1/4 inch. I don't think I had a 1/4 inch drill bit. I had like a 281 drill bit that was carbide, and I didn't have a 1/4 inch carbide drill bit. These jaws aren't super hard. They're about 50C, I would guess. You could probably use a cobalt bit, but that's the key. And I'll tell you the truth, I didn't even dress the wheel. I know only half the wheel or less was hitting, but it still did a good job. Okay, this thing did a freaking awesome job. I didn't want to dress the wheel just because get more grit all over. And yes, I covered the lathe. But I still, you know, I was only grinding for 10 minutes. And, you know, I didn't think I needed to dress it. Call me a hack, but it worked. Now, and I had to take the chuck off and clean it in the parts washer, right? Clean it in the parts washer. Turn on. This thing works great. It's I think it's a 45-gallon drum. And, you know, I got the pump inside, and this works for me, man. It works great. Oh, one thing I wanted to show you, this top shelf, it's just a blue shelf made out of sheet metal with a little stand. I keep my brushes up there, and, you know, I got different brushes, wire brushes, bristle brushes, brass brushes, just kind of brushes. I keep my stones up here because I do a lot of stoning with the mineral spirits, because then they don't load up, right? But this I used on the chuck jaws. If you can, pick yourself up some round stones. This is India. And that's what I was stoning the final grind to make it, you know, smooth, deburr it. You know, I got, this was a stone. I dropped this stone and I broke it in half, right? It looked like that one. And I dropped it and broke it in half, and then I just took the grinder and I cut the BS jagged edge off, and now it's two little smaller stones. But I use this a lot, and you know, I ended up going on eBay and buying another stone, a full one, because I had two. See, one's like a brick red and one's an orange. You know, they're both India, but the brick colored one is finer, just a touch finer than the orange one. And then I had this in a box. I never used it. This is also in India. It's made by Norden. India is the type of abrasive, even though this is probably alundum or carborundum or something. And these are all flat, you know, lapped on a diamond master. I know I get off topic, sorry, but yeah, that's a handy shape stone. Yeah, you gotta be careful. And I got some coarse, really coarse ones. This is a die polisher stone, and like this is, that's a corundum. That's soft. The bond on there is soft. This used to be twice as thick, and you see how it's tapered. This used to be twice as this was 5/16. This is more than a 1/4 inch when it started. But the bond is loose and the grit comes off, which is okay. I use this for stoning tables until I had something better. All right, enough with the stones. So these grip a shaft perfectly now. There's no bell mouth. Really good. Now, if there was a lot of wear in those slots, and I checked them, there's only, I don't know, 2, 3, 4, 5 thousandths of wear. If you get a lot of wear, which you can do, these buck chucks, there's 6 screws on the face, and there's 6 on the back on the perimeter. There's 1, 2, 3, 4, I guess there's 12. You know, there's some on the back. What you can do is these, see this surface, there's the scroll, right? There's the scroll, and that rotates. This surface here, right? That's the chuck body. You know, next to the scroll is the chuck body. If you take the chuck apart and you just run the back in the lathe and turn, you know, face off this, face 3 thousandths or 2 thousandths or 4 thousandths off of this, and then if your slots, your T-slots are splayed up in the center, right? Like they're gonna be worn here underneath, right? On the bottom of that T-slot, they're gonna be worn. and the jaw is going to come up. Well, if you turn this surface down, say you turn that down 3 thousandths, start slow. Start with 2 or 3 thousandths. Put it back together. You know, put the front on the face on the chuck. Put all the bolts in, torque them up, and then put your jaws in. And that's one way that you can kind of repair, you know, those T-slots. If they're worn and they're going to wear underneath towards the middle, where they seat on, grind that down 2 thousandths or 3 thousandths or 4 thousandths, and then the whole, like, this is so hollow because there's 6 cuts in it, it's going to flex, right? It's going to flex that face, and the part that's worn, it's going to bring it back into plane again. And you might say that it's sort of a hack thing to do. Well, the chuck is junk otherwise, and it's not worth the powder to blow it to anywhere in a screwed up condition. So that's one method you can do. If this grind didn't clean up, it had to take too much, I would have done that. But I think I only took off 5 thousandths when I ground the jaws. If this was really sprung, where, you know, I would do that. And because you have to grind less off. You might not have to grind any off. But anyways, that's that. I have I don't know how to pronounce it. It's a Harding Sjogren. S-J-O-G-R-E-N. Sjogren. I think it's Swedish. I don't know. Collet chuck. This is 5C collets, and you know the lathe mount is a D16. When I bought the Harding HLVH lathe, the guy threw it in because he thought it was, I don't know, he didn't know, he thought it was for that lathe. So I needed to do some work on here before, you know, close tolerance work before I ground the jaws on the buck chuck. And I got everything clean and put it on, and there's there's 1 full thou run out on the collet, there's 1 full thou run out on the taper where it goes in the nose. So you see this front face, there's a grease fitting and, you know, 4 bolts. I thought you could loosen these bolts and tap this around for concentricity, because I seen somewhere on Practical Machinist or something, somebody showed that. You cannot do that with this, because I took it apart, and the planet gears are on pins, right, dowel pins or some kind of pins, and the pins stick half in the back part and half into this nose cone. And you can't really shift it hardly at all to achieve better run out, because the pins that are the axles for the gears, they kind of tie everything together. So I tapped it a little bit, and maybe it's down to 8/10. But I need to grind this if I want it more perfect, right? But I'm not going to do that until I put bearings in this. I've got the bearings, I need to put them in, whatever. But anyways, that's kind of what I was working on with that. So if you enjoyed that, hope you got something useful out of it. If you have any questions or you want me to make another video about how to do this better, I can do that. Let me know. Okay, on the Hendy tool and gauge maker lathe, I showed you guys a while ago, you know, I love handles and knobs, and these power feed clutches, they used to have round ball knobs like the half nut lever. They just had round ball knobs on the end. But I found out that these teardrop handles, these are from the table locks of a Bridgeport, like a real Bridgeport, not an import Bridgeport. These are genuine Bridgeport pieces. So that, and they're longer too, and I had to turn up the spring pressure a little bit to keep the clutch from slipping. But these look super cool, I think, right? And then, I don't know if I saw it somewhere or I got the idea, I put a teardrop handle on the forward reverse knob, right? So that knob is just an aluminum knurled knob. It's about 1.5 inches 1.25 inch diameter, something like that. Forward, off, reverse, off, forward. But I put it in there, drilled and tapped it, and I had to spot face it at a 30-degree angle because I didn't want it coming out straight. I liked the fact that the angled look, it just appealed to me more. It looks more proper. Oh, it's just so nice in the hand. It's such a pleasing shape. I know it's not exactly, but it kind of reminds me of the tip of a St. Rupert's drop. I think that's what you call them. Those really hard drops that there's some physics about them that makes them wacky strong. But it's, you know, silly little stuff like that, you know. You can see the tag reverse stop forward, and it just looks cool, right? It looks neat. This is the shuffle for the threading, forward and reverse. I was thinking about a little bit of maybe a baseball bat, something for this. I don't know. But anyhow, I think, let me get a shot where you can see, you know, that handle and those two, those are my upgrades. I think it's very tasteful. And it's silly, right? It's silly, but that power switch, it just needed something. That little round thing, you know, you could fumble and figaro around to try and, you know, it's better with the bat on it, with the little teardrop, you know. And actually, that one, I replaced these. I cannot see. Yeah, that's, well, here you go. These are cast aluminum, and what I did is, the reason sorry, I'm shaking. These are indexable, right? You pull this out, and then you put, you know, there's a spline in there, so you can index these. And these were great. I mean, you buy these from the Bridgeport parts people on eBay. And they're nice. They're very similar. They're not the exact shape, but they are darn close. So I took inspiration from that. And when I bought these are 1/2 inch 13 thread that Bridgeport uses. My cables for the DRO isn't in the way, but you see what those are. And when I swapped out these, I had one left over. Handle, and this actually is the handle that came from the Bridgeport, and the other two I actually bought from Matco on eBay, or, you know, their online store there. So, but I love machine handles. I love controls. This handle was smashed. This hand wheel was smashed. And I adapted this one on, and this, I think, is from either a Delta Rockwell table saw or a Delta Rockwell, that small surface grinder that they made. You know. Anyhow, I hope you enjoyed my little knob modification with the teardrop handle. I like it. It just gives me the fizz, as they say. Alright, hope you enjoyed it. Doozer Shop. I wanted to show you one quick thing with this engine block. This is from my International truck. It's a 264 cubic inch. You might remember I was talking about modifying the oil system and creating a separate oil filter that was full flow. And I talked about a little bit, this is there's an internal passage that goes from the main bearing to the cam bearing, right? And then there's a Y in the middle, and it intersects with this, right? And this goes through. So that tubing goes through the main gallery, blocks it off, and then goes to a Y that goes up and down. So as I talked about before, feeding this piece of 5/16 tubing would directly oil the cam and the main crank bearings. So what I came up with is this. This is a piece of 11/16 bar stock. I think it's 1144, and it's just got a center in it. I didn't drill it yet for a 1/4 inch, but it's 5/16 outside diameter, and I cut a nice long taper 1/8 inch pipe thread on there. Okay, it's still solid. I didn't cut it through yet or drill it through yet. So to make that 1/8 inch pipe taper, I used the taper attachment on the Pratt & Whitney lathe. So that's a factory end on a piece of 1/8 inch pipe. And I just made the taper a little bit smaller and a little bit larger. It's still 3/4 per foot, which is a 1 in 16 taper. And I just, this is my test piece, is the actual 1/8 inch pipe. And I tried to do it on here. So I used the taper attachment on the Pratt & Whitney lathe. So what I did is I roughed this out to 5/16, and then it steps up to 3/8, I think a little under 0.370, and it ends at 406, 407, 408. And I just cut my taper on there with no threads, of course, first, and then you put the threads on a taper. And that's what a taper attachment allows a lathe to do, is to cut threads on a taper as well as straight cylindrical conical turning on a taper. So this is my fit 'em up piece, right? And I got another, for check and fit, I got an 1/8 inch coupling there. So what I do is, you can see it'll cross the main gallery in there. Come on now, I can't get it back in. Okay. So the block is factory tapped for 1/8 inch pipe thread, and I've got 5 turns of engagement, right? And yeah, it's a little longer, whatever. That's 5 turns of engagement. I think that one is 5 3/4, and the back one is 6. I can run the tap in here a little bit deeper and get one more thread if I want to. But anyhow, imagine that's hollow and drilled out to 1/4 inch. So, and I'm going to put not a flare fitting, flare fitting, not compression, but flare, to use 3/8 tubing with a flare nut on the 3/8 copper tubing. I could use 3/8 steel tubing, doesn't matter. But anyways, that allows me to feed oil into the gallery, feed oil into the mains, bypassing the gallery, because the gallery is unfiltered oil. So, like I said, that ends up, oh golly, for the love of camera, it ends up right about there, and imagine that there's another cross hole. You can even see that hole? That's where the cross hole goes down, and there should be one up in there, and I don't have the flash lamp. But anyhow, so that's what I kind of came up with. And I got to make 2 more, one for almost the back and one for the back. In this one I can just use the tubing, because a bolt-on flange goes on here. So that can go into there, and I can put that into the bolt-on flange. I'm going to take oil pressure off of there to go to the filter, or actually whatever, it doesn't matter. But that's kind of what I'm going to do. But just having the Pratt & Whitney lathe, and I was learning how to use it because each taper attachment is sort of different. So I'm kind of proud of that. My first little foray on this lathe, at least, into taper cutting. So just a quick kind of, and then the deal is I'd have to make an inline 4-into-1 manifold to manifold all these 4, oil injectors or whatever you want to call them, log them together to you know, receive the oil coming from the oil filter. So whatever. All right, hope you enjoyed that. Working on the international engine block. Till next time, Doozer Shop.